So here's the deal. This is really kind of similar to what we did yesterday. So yesterday, you'll remember last week, we were doing prisms. And prisms, I probably shouldn't even attempt to draw it, but prisms were the things that are three-dimensional, and you have two sides that are identical. Did okay up until that last line. But so you have two congruent sides, like that are parallel and identical. Yes? Within the limits of my drawing. So they always had two bases, and the bases were parallel and congruent. Pyramids, really this section is two different things. We have pyramids and we have cones. We're going to learn a new special equation for cones. It's on that little bookmark you got. And pyramids are just, you kind of hack your way through it like the section before. With those, let me get rid of that. Pyramids are different from prisms in that they only have one base. So if you're looking at these, if the base is what it's sitting on. That one is a triangular pyramid. The base is a triangle. It's possible to have a square pyramid. So it has a square base. All the sides are triangles in. Or this one here is a hexagonal. But you could have ones that are pentagons and so on. Good? The key is just one base. So pyramids, what do I want to say about it? Flip my notes back over. And so one base. And all the other faces, or all the other sides, are triangles. So I'm going to say triangles for all other sides. Work for you? And once we're done with that then, now we have two different options for height. And let me switch to a little bit smaller color thing there. Okay, so height. Normally when you talk about height, it's kind of like how tall is this thing, right? If you're trying to fit it through a doorway, how tall of a doorway does it have to be? So height is going to be this here. And I'm going to say for that one, height is the how tall. And it goes from that very top point. You could call it the vertex if you want, or one of the vertices anyways. But basically, it's from the top to the middle of the base. And that's going to be true whether it's a square base like this one here, if it's a hexagon or a triangle or something like that. But the height is going to be that line there. Does that work for you? The slant height is looking at how tall is one of the sides. So this here in red they have is the slant height. So I'm going to say this one here is the height along a side. Now, of those two, say we're talking about surface area. Which one of those two do you use in surface area?
Slant height.
Perfect. Because we're going to be looking for, what's the area of this side of the triangle, that face, you could say. And it would have to be that slant height is the height of that sloping brown side. Agreed? Mm-hmm. So then you could say the slant height is used for surface area of the sides. All right. How you feeling? Okay for those? Then, if we had to find that, we're going to do this example down below. And I picked a nice one because it gives us the height of 3 feet right here. It gives us a slant height of 5, so we're good. But sometimes you won't know the slant height and you have to find it. How could you find the slant height if you knew the height? Go for it, Katie. Don't see it? Well, if I were to take and connect these two, and it's a little hard to kind of picture, but if I would connect those two, what type of shape do I have now in colors in this thing here? Triangle, and it's not just any triangle, it's a right triangle. Do you remember finding missing sides on a right triangle? We could say A, B, and C. C always has to be the hypotenuse, that longer one, and A squared plus equals C squared. So that slant height is going to be that C is going to be the hypotenuse. You'd be able to find the slant height using this equation from the height. Or you'd be able to find the height if you know the slant height and kind of the length along a base. So that's going to come up a little bit later on, not right now at the beginning. So, all right, ready to keep going? So kind of store that away. You'll see that later on in the notes. So finding the surface area. And I can't erase what I scribbled out, so I'll write my 5 feet back in. All right, just like before, if we can find the surface area of each of these parts, of each of the little parts there, add them all together, we have the total surface area. Agreed? Start with the triangles or start with that square? What do you think? Square? Okay.
10.
So if I would do this square, area of a square, you could say base times height, or you could say side squared. Doesn't make any difference. Base and height or the length of a side in this are all going to be 8 feet. So we have 8 feet squared, or 8 feet times 8 feet, for a total of, nice, 64 square feet. So that's going to be that middle part, 64 square feet. And I'm hoping I can get you to show your work kind of like this as you do the homework. That's where kind of going around today. It's like, oh, where's your work? You know, if you write the equation, put in the numbers, just easier to get it right. All right, each of our sides now, this shape here is a, so we say area equals, perfect, half base times height. Or some people do base times height, divide it all by 2. And now if we go back over to our picture on the left, the base, I guess we're talking about this one, you could call this the base, and then the height always has to be perpendicular to the base. Agreed? So the base we could say is 8. Nice. And the height is 5. Good, because it's that slant height, because we're talking about this triangle that's kind of on an angle here. And 4 times 5 is 20. That'd be 20 fair square feet. Maybe I should have put parentheses up there. Okay. Now we have how many of those triangles?
4.
So that's the area of each triangle. There's 4 of them. Total area of the triangles is 80 square feet. And now final answer then? 144. You could take your 64 square feet. Okay. So this here was the area for just one triangle. Does that work for you? And then we have 1, 2, 3, 4 of them. So I multiply by 4. And now I have right here the area of all 4 triangles. What's that? So 64 square feet plus my 80 square feet. And you guys were telling me it's 144, right? So 144 square feet total. Yeah. All right, questions? The second part of the notes, we're looking at cones. And for cones are kind of weird for doing nets of. But a net for a cone is going to look like this thing down here. And the way that you kind of put it together, and I don't know if I'd mess up your drawing like this, but that if this here is the circle with a circumference, that's like the base of the cone, that'd be like this thing here. And now in my net, this here should be that same length. And in my mind, this looks longer than the circumference. But that there is going to be the part that actually wraps around the circle and kind of fills it in. So this edge here is going to kind of connect with this edge kind of at the end. And this here is going to be that very tip at the top. Can you kind of picture it?
Yeah.
And if your cone is like really tall and skinny versus short and squatty, what's going to be different is it's just going to take and change the kind of where that point is. You know, maybe it'd be something like this here, that would be more of a short and squatty one is going to look like that, and then this part here would be all cut off. Fair enough? But you don't really have to worry about that much at all. We have a nice equation, you just take and plug it in. So cones, I'm going to take and right up here by the cones, write SA for surface area and for a cone. Actually, I probably should do the bullet points first. So soon, in a moment, but not yet, we'll have the equation. But cones has one base, and the base is what shape? Nice. Base is a circle. We have that base there, this base here. Drawn right would be a nice circle. And we have only one vertex. Because a vertex was kind of like the corners. There's only one corner in each of these, and it's going to be at the very top. And again, you have the height, you have the slant height, that type of thing there. But to find the surface area, we need to find, well, what's the surface area of the sides, which would be this part, and then what's the area of the base, and add them all together. But they just do it in one equation. So area of a side is going to be 1/2, then a capital C. What does capital C stand for? Circumference. So I'm going to just put a little arrow to it and say circumference. So 1/2 capital C and then a lowercase s, and the lowercase s is the slant height. So kind of the height along the side, the slant height. So that part right there, the 1/2 CS, gives us the area of, all the sides, all this part down here. Now, all we have to do is add in the area of the circle. And the area of a circle is pi, anyone? R squared, pi r squared. So that equation in red now is going to be the equation you can use for any cone to figure out the surface area of it. Do one of those and we're done. So if you're still copying it down, I'm going to write it right here. Stick with me, friends. We're almost done. Plus pi r squared. All right. If we do this, so surface area 1/2 times c. So we have 1/2. Well, we need to find circumference, right? So circumference, you could look at your bookmark with all the equations, or maybe remember it's going to either be pi times diameter or 2 times pi times r. Which one are we going to use?
Diameter.
Yep. Pi times diameter, because they give us the diameter. They give us that 30. So we have a pi times 30. And now you have a couple options. I would encourage you, even though it seems kind of weird, well, pi is an ugly decimal, right? It's irrational, one of those decimals that goes on for forever. So if I type in 30 pi in my calculator, I get 94.24777,961. Then it keeps going even though my screen doesn't have it. I'm actually going to write this problem twice. I'd encourage you to just do the top way, but if it's totally blowing your mind, you can kind of cave and do the other one. But so 1/2. Circumference we just found is this 30 pi. So I would recommend writing 30 times pi right there. So this top one is the way I like doing it. The other option is to put in the decimal, so 94.2. But that 30 pi doesn't have any rounding. As soon as I round this ugly decimal to 94.2 or 94.25, I've introduced some rounding. All right, now let's go and find the slant height. So slant height's going to be this here along the side. And we find that by doing a squared plus b squared equals c squared. Now S, the slant height, has to go in for which letter? A, B, or C? C. Because when we're talking about a right triangle here, it's the hypotenuse. It has to go in for C. And that'll be the case every single time. A and B have to be the two legs. So this could be A or this could be A. It doesn't matter. Agreed? So I'm going to have A just be the height, B be the radius there. So for A, I could put in a 20. So 20 squared. For B, I'd put in, trick question, kind of. Is it 15 or is it 30? 15. Because 30 is going to be all the way across. Do you agree my triangle is only the radius from the center to the outside? So we have to take the 30, the diameter, and cut it in half and get the 15. All right, so 20 squared plus 15 squared. Do you have a question? Okay. So we get 625 equals s squared. I don't want s squared, though. I just want s. So what do I do to s squared? Square root it. And I get a 25. So I could put the 25 in for the s. Okay, we all right for the first part? Because that's the new part, that's the challenge. Any questions? You maybe already did. All right, so finishing it off, we have plus pi, and what do I put in for r? 15. Pi times 15 squared. And if you take and punch all of those in, if I were to do this bottom one, I'm going to get 1884. So if you did the top, I wouldn't write this down yet, but 1884.4. And all the units in there are feet, and it's an area, so it's going to be square feet. So that's what we get if you round that 30 times pi to 94.2. If you do that exact same thing, but leave it as 30 pi, then you get one similar, 1,884.96. And this top one I like more because it doesn't have any rounding at all in the problem until the very end. It's 1,884.9555592, and then the calculator keeps going. But when I just round at the very end, I only rounded once. Here, I rounded, but then when I multiplied by 1/2 times 25, I just made my rounding 12.5 times bigger. So I'd encourage you to wait and do it like that, just round once at the end, but push comes to shove, you can get that and be okay. So, work for you guys? All right.